Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to see solution of the problem, find the number of islands. First of all, let us start by understanding the question. What does question say? It says that given a grid of size n cross m where n is the number of rows and m is the number of columns in the grid consisting of zeros, water and 1 lands. Find the number of islands. So basically we are given a 2D grid and value of each cell is either 0 or 1. Whenever there is 0, we consider it as water, and whenever there is 1, we consider that cell as land. So we need to find how many islands are present. Now what is an island? An island is either surrounded by water or boundary of grid and is formed by connecting adjacent lands horizontally or vertically or diagonally, that is in all 8 directions. So an island is formed by connecting adjacent lands. Now what is lands? The cells which are marked as 1. Connecting adjacent lands. So by connecting all the adjacent lands, so connecting all the cells which have marked as 1. And what is the meaning of adjacent? The lands which are either horizontally or vertically or diagonally adjacent, that is in all 8 directions. So let us look at the example for better understanding. Suppose we are given a grid here. So this and this all 5s are land, these all 5 ones are land, and these 3 zeros are water. Now this one and this one is connected. How? Because they are diagonally adjacent. This one and this one is connected, they are vertically adjacent. This one and this one are connected because they are horizontally adjacent, and this one is also connected because they are vertically adjacent. So basically all the ones are connected, so basically they form only one island. Okay. Also viewer said that the island is surrounded by either water or by the boundary of the grid. So if we look at this point of the island, on the right hand side it is surrounded by water, on the left hand side it is surrounded by boundary of the grid, and also on the bottom side. So that is why it is said that the island is surrounded by either water or boundary of the grid. So all lands are connected, so we have only one island. If we look at another example, then if we look at here, these 5 ones are land and this one is land, other zeros are water. So now this and this are connected, this one and this one is connected, this one and this one is connected, and this one and this one is connected. So these 5 ones together form one island, because an island is formed by connecting adjacent ones either horizontally or diagonally or vertically. So all these 5 ones are connected, so we get one island. This one is not connected to any of the ones, so this is another island. So total there are 2 islands, so the answer is 2. Okay. Your task is to complete the function num islands, which takes the grid as an input parameters and returns the total number of islands. The expected time complexity is big O of n cross m, and expected space complexity is big O of n cross m. So now if we think about solving this problem, then here we need to find the number of islands, right? And what is an island? It is formed by connecting ones which are adjacent to each other, or connecting lands, which is basically means cells having value 1 which are adjacent to each other. And here adjacent we consider 2 ones if they are horizontally adjacent or vertically adjacent or diagonally adjacent. So these 2 are also adjacent and connected to each other, these 2 are also adjacent and connected to each other, and these 2 are also adjacent and connected to each other, right? Now how can we solve this question? In graph, one similar question we have, that is find the number of connected components in the graph, right? So for example, if a graph is given, suppose this is 1, this is 2, this is 3, and suppose this is connected, then we have 4, here we have 5, and here we have 6. Suppose this is the graph and we are asked to find the number of connected components. How many connected components are there? 3. How can we find the number of connected components? We can loop from I equals to 1 to n, that is node number 1 to n, and for each node which is not visited before, we will call a DFS on it and visit all the adjacent nodes to it. Okay, so we will visit all the nodes in that connected component, and the number of such DFS required will be equal to number of connected components. So for example, here what will happen, I will loop from 1 to 6, so 1 2 3 4 5 and 6, right? And here if I write down DFS number, then is my I visited before? No. So I'll call a DFS on it, mark this as visited. From 1 I can go to 2 in a DFS because those 2 are connected, mark it as visited. From 2 I can go to 3 because 2 and 3 are connected, so I'll mark it as visited. Now I cannot go any further, so I'll backtrack in the DFS and come back to the main function. I did one DFS starting from I equals to 1 and visited 1, 2 and 3. So 1, 2 and 3 are visited, and one DFS is called on this. Now my I will go from 1 to 2, but 2 is already visited because it was connected to 1, right? It was adjacent to 1. So I'll not call a DFS on it. It is not a new connected component. It is already visited. So the connected component having 2 is already counted. So I'll not call a DFS on it. Then then my I will go to 3, but 3 is also visited, so I'll not call a DFS on it. Then my I will go to 4, 4 is not visited, so I'll call a DFS on it and mark it as visited. From 4 I can go to 5, so I'll go to 5 and mark it as visited. So here my second DFS was called. Now can I go further from 5 anywhere? No. So I'll backtrack and come back to the main function because no adjacent nodes are connected to 4 and 5 which are left to visit. Okay. So number of DFS will become 2 and my I equals to 4 gets visited. Now my loop will go from I equals to 4 to 5, but 5 is already visited, so I'll not call a DFS on it, right? Because 5 is a part of the connected component which is connected to 4, and on 4 we already applied the DFS, right? So now my I will go to 6 and we'll see that 6 is not visited before, so I'll call a third DFS on it and mark it as visited, right? So total number of DFS required to mark all the vertices as visited are 3. So the number of connected components is 3. In the first DFS, I was able to mark all those 3 as visited. So I didn't call DFS on 2 and 3 because those were a part of the connected component which had 1 already, right? And DFS on 1 was called. Next DFS was called on 4 and third DFS was called on 6. So basically now this is the number of connected components in a graph. Here we need to find number of islands. So can I convert this question into this? Yes. How? I can ignore all the zeros and all the ones. I can consider each cell as a node. Okay. I can consider each cell as a node and I can imagine an edge between two ones which are adjacent to each other either horizontally or vertically or diagonally, right? So here if I consider this one, then this one is connected to this one, it is also connected to this one diagonally, it is connected to this one vertically and connected to this one horizontally. So I can say, let me call this A1, A2, A3, A4 and A5. So A1 is connected to A2, A1 is also connected to A3 because we consider two ones adjacent, either they are horizontally adjacent or vertically adjacent or diagonally adjacent. So A1, A2 and A3 are connected. Now A2 and A4 are connected, A4 and A5 are connected, right? Zeros we can ignore. Now let us call this as A6, okay, this one. So that is separate, A6. Then I can consider this as A7, okay. So I can say this is A7. It is also independent, only one vertex is there, and these three are also connected. So let me call this A8, A9 and A10. So A8 and A9 are connected, A9 and A10 are connected, and there is also an edge between A8 and A10. A8 and A10 because those two are diagonally connected. So this A1, A2, A3, A4, A5 are here, A6 is here, A7 is here, and A8, A9, A10 are here. Now no more are left. So is this question similar to this? Now find the number of connected components in this. This is 1, this is 2, this is 3 and this is 4. So the number of islands is how much? 4. So basically what we can do is we can imagine our 2D matrix as a graph. Each cell is considered as a node and two nodes have an edge between them if both of them are 1 and both of them are diagonal to each other, adjacently diagonal to each other, or horizontally adjacent to each other, or vertically adjacent to each other. In this way I can consider a graph, and starting from this row I can visit each and every cell, and if the value of the cell is 1 and if it is not visited before, I'll call a DFS on it. So starting from here, my first DFS will be called on A1. So when I'll call a DFS on A1, all this will be marked as visited, right? So now I'll come here till here. So this will be marked as visited in one go, right? So this will be counted as 1. Then I'll come up to here. This cell has value 1 and it is not visited before. So I'll call a DFS on it and mark it as visited. Then I come to this row. Now this is 0, this is visited before, so I'll not call a DFS on it. This is 0, these two are visited before, so no need to call a DFS on it. These two are 0. Again I'll come till here, these are all zeros, just ignore it. here I'll call a DFS because it is 1 and not visited before. So in that I'll mark these 3 cells as visited. Okay, so this would be my third DFS, and then these 3 would be marked as visited. Then I'll come here, this is not marked as visited and this is 1, so I'll call a DFS on it, and all of these are zeros and these 2 are already visited. So basically I'll need to call 4 DFS to mark all the ones as visited, which are basically considered as nodes. 0 you can ignore it, and 2 nodes are connected to each other if they are adjacent to each other vertically, horizontally or diagonally, and they have the value 1. Okay, now let's look at its actual implementation. So now if we look at the actual implementation, so I have taken an answer variable which is initialized to 0, taken some variables, taken n as the size of the grid, and that is the number of rows, and m as the size of the 0th row, so basically number of columns. Then I have taken one boolean variable, boolean 2D array of size n cross 501, which will basically, during a DFS, whenever a particular node is visited, we mark it as true. Here each node will be represented using a row number and column number. So basically this V is used for that. Whenever we will visit a cell, we will mark it as true. So I have initialized all of them as false initially, and then for I equals to 0 to n and j equals to 0 to m, if it is not visited before and if it is a land, so if grid of ij equals to 1, then I'll call a DFS and I'll make answer plus plus. Okay, because the number of times this condition holds true and the number of DFS I have to call, those are the number of connected components. So I'll call DFS starting with the ith row and jth column cell. I'll pass the grid value because I need to see which cell has value 1 and which has 0. I'll pass the number of rows, number of columns, and I'll pass the visited to the array, and finally I'll return answer, which will be nothing but the number of times this condition went true and we called the DFS, right? So this will return me the number of connected islands. Okay, number of islands. So now let's look at this DFS function. So if we look at the DFS function, then it started with row number R and column number C. This is the grid we have passed n, m and visited. So first of all, in DFS, what we do, whenever we visit a node, we mark it as true that it is visited. Then I have taken I and j and looped from -1 to 1. Why? Understand one thing. So two cells are adjacent to each other if they are horizontally adjacent to each other, vertically adjacent to each other, or diagonally adjacent to each other. So suppose at present I am at a cell which has the row number R and column number C. So this cell is adjacent to it, it has row number R minus 1 and column number C. This cell is adjacent to it, which has row number R and column number C plus 1. This cell is adjacent to it, which has row number R and column number C minus 1. This cell is adjacent to it, which has row number R plus 1 and column number C. This cell is adjacent to it, which is row number R minus 1 and column number C plus 1. This cell is adjacent to it, which is row number R plus 1 and column number C plus 1. This cell is adjacent to it, which is row number R plus 1 and column number C minus 1. And this cell is adjacent to it, which is row number R minus 1 and column number C minus 1. So basically, in R and C, what am I adding? I am adding -1 -1, -1 0, -1 plus 1, 0 plus 1, 0 minus 1, plus 1 minus 1, plus 1 0, and 1 and plus 1. So basically all the combinations of 0, 1 and -1 I am adding, right? Only one combination is not adding, which is R plus 0 and C plus 0, because that will result in the same cell. So basically all the combinations, if I am taking R plus I and C plus J, then all the combinations where I equals to -1 0 plus 1 and J equals to -1 0 plus 1, all these are considered, but total number of combinations will be how much? 3 into 3 9, but we are considering only 8 adjacent, because one combination 0 and 0 will not be considered, right? So in order to generate those, I have taken I equals to -1 to 1 and J equals to -1 to 1. Now if I is not equal to 0 and I is not equal to J, right? So this condition will hold false when I will be equal to J as well as I will be equal to 0. That means I equals to J and I equals to J equals to 0. So we do not want this case. So whenever that case is true, we will not go inside. In the remaining 8 cases, we will go inside. Okay. So now the adjacent cell to R and C is which one? R plus I and C plus J. So the first condition is it should be within the boundaries. So if r plus I is less than n and r plus I is greater than equal to 0 and c plus j is less than m and c plus j is greater than 0, then so basically this cell with row number r and column number c has the value 1. Now we are looking for the adjacent cells which has value 1. So we can traverse them and mark it as true. So first of all, we'll check whether that adjacent cell is within the boundaries. If it is within the boundaries, it should not be visited before and the value of that cell should be 1. That should be land. Only then we will call a DFS on it. Okay, so it will count all the adjacent ones which forms an island, and the number of times DFS is called will be equal to the number of islands. And what would be the time complexity? See, basically we are applying a DFS. In DFS, the number of time complexity is V plus E, right, where V is the number of vertices and E is the number of edges. How many vertices do we have? We have n cross m vertices because each cell is considered as a vertex, right, in the 2D grid. How many edges are there? Each cell is connected to 8 adjacent cells, right, at max. We are not considering the boundaries. Okay, let's take up a little general case. So each cell is connected to 8 adjacent cells, but one edge is common between 2 cells. So I can say total number of edges are less than equal to, we can give an upper bound of how much? 8 times number of cells divided by 2, because one edge is common to both of them. So plus 4 n cross m, but this becomes 5 n cross m, but 5 is a constant, so we can say time complexity is nothing but big O of n cross m. What will be the auxiliary space? The auxiliary space here required is what? We are taking one Boolean array of size n cross m, which will basically mark whenever a node is visited. Otherwise, we are taking only a few variables. So I can say auxiliary space is also big O of n cross m. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.